Hello my dear students, today we are going to apply activity 2 about volume on the book pages 146 till 148. Activity 1, space occupied by a body. The following document represents various objects that we want to put in the bookshelf. So we can see here a big bookshelf. And we have to place these objects in their places. We have loudspeakers, books, television, and vase. They numbered the places in the bookshelf 1, 2, 3, and 4. So we have to indicate if all the objects that we want to put in the bookshelf occupy a region of space. Do all these objects occupy a region of space? Do they take up space? Yes, they all occupy a region of space. We have to indicate if we can put the television in box 3. This is box 3 here. Look at it. Does it fit for the television? Can we place the television here in box 3? Of course not. Why? Look at the space. This is a small space, whereas the television needs a large space. So we write, no, we can't put it in box 3 because it occupies a larger space than the box. Now number 2, we have to match each object to its convenient box in the bookshelf. So we have to place these objects in their correct places, either in 1, 2, 3, or 4. Let's start with the loudspeakers. Where do you think we can place the loudspeakers? Do they fit here? No. Do they fit here in box 3? No. We have 2 places for the loudspeakers. We are going to place them here, one on each side. So loudspeakers are placed in box 2. What about the books? Where can we arrange them or put them? Yes, we can put them up here. We will arrange them on the shelf number 4. The television. The television is the biggest one. It has its own place. It has the largest space. It is here in number 1. What about the vase? The vase will be placed here in number 3 because it fits here. So we write them on the line. Number 3. Complete. Every object occupies a certain region of space. Different objects occupy different spaces. So each object has a certain volume and it occupies a space different from the other object. Part 2. Volume of a body. The volume of a body is the region of space occupied by this body. So as we said before, the space taken by matter or by the object is called volume. The amount of space is called volume. Now let's look at the picture and answer the questions. Compare the region of space occupied by the child to that occupied by his school bag. Which one occupies a bigger space? The child or the bag? Of course, the child. So the child occupies a larger space than the space occupied by his school bag. Draw out a conclusion about their volume. What do we conclude about the volume? Whose volume is larger or bigger? Yes, right. The volume of the child is larger than that of the bag. The document below represents objects of different volumes. We can see a microwave, a refrigerator, mobile phone, and washer. Each object has its own volume. It takes up a certain region of space. We have to arrange these objects in ascending order of volume. And what do we mean by ascending? It means increasing. As increasing and decreasing are opposites, also ascending and descending are opposites. Descending, decreasing, ascending, increasing. And increasing means that we have to write them from least to greatest. We start from the smallest one. Look at the objects. Which one takes less space? It has the least volume. Yes, the mobile phone, then the microwave, then the washer, and at last, the biggest one is the refrigerator. Number 4. Complete with the convenient word. The region of the space occupied by a body corresponds to its volume. So we call it volume, the region of space. The body occupying the largest space has the largest volume. Since space is the same as volume, so the one with the largest space has the largest volume. Volume is one of the characteristics of matter. Do you remember? We say that matter is everything that has mass and takes up space, which we call volume. So that's why volume is one of the characteristics of matter. The last part, objects in the same space. Look, we have a bookshelf. This bookshelf is filled with books. We want to add one more book. Do you think we can do it? Is there space for one more book? Look well. The bookshelf is full with books. So, now I want you to look well and specify if all the books have the same volume. Look at them. Do they all have the same size? No. Some are tall, some are short. Also, some are thin, while others are thick. So this means that they are not all taking the same space. So they do not have the same volume because they have different sizes and thickness. Number 2, indicate if more space is available to add other books on the shelves. Look well, do we have a free space to add more books? No, there is no free space to add more books. In your opinion, what should be done so that another book can be added? If it is full and I want to put a book on the shelf, what should we do? Some books should be removed to be able to add another book. So since it is full, I have to remove one or two of the books in order to replace it by another book. Number 4, complete with the convenient word. Two bodies cannot occupy in the same conditions the same region of space. So that's why I cannot put two books in the same place at the same time. Each of them has its own volume and occupies a determined space. As we saw yesterday, we couldn't place the water and the juice together in the bottle. If the bottle is full of juice, there will be no place for the water. Either I have to remove some of the juice or all of them to add some water. So two kinds of matter or two objects cannot take the same space at the same time. Now, how can we find the volume of an object? This is an extra activity and I want you to pay attention because it is very important. Let's say I have a piece of rock and I want to find its volume. It has an irregular shape. I cannot use a mathematical rule. So look what we're going to do. We are going to place a certain volume of water in a graduated cylinder. This is the graduated cylinder. It is graduated with numbers. We're going to put some water. For example, here we put 20 milliliters. Then we drop the object in the water and measure the new volume. Look, we dropped the rock. Now the rock is in the water and there is a new volume. What was the volume of the water before we placed the rock? It was 20 milliliters. And after dropping the rock, the volume of the water became 30 milliliters. So the water and the rock together are 30 milliliters, because in the graduated cylinder we have rock and water. Now, what is the volume of the rock? How much did the water rise up? It increases 10 milliliters. 30 minus 20 is 10. Be careful, we didn't add more water. We still have the same amount of water. The water is still 20. But when we dropped the rock took place instead of the water. Do you remember when we said before that two things cannot take the same space at the same time? So the rock pushed the water up and took its place. Now the water rises up. How much did it rise up? It rises up 10 milliliters. So this extra volume from 20 till 30 is the volume of the rock. The rock made the water rise up 10, so the volume of the rock is 10. This method, which we are using now, is called water displacement method, because the object is displacing the water. It is moving up the water, taking its place. We call it water displacement method. This is another example. How can we find the volume of each ball, knowing that the balls have the same size? So the red balls are equal. We have to find their volumes. As we said before, we have to put a certain amount of water in a graduated cylinder. You can see that we placed 4 milliliters in the first cylinder. Okay, then we dropped the two balls. So the water rises up. How much is the new volume? It is 6 milliliters. This means that the water and the balls together are 6 milliliters. If water is alone, 4, and the new volume is 6. So how much did the balls increase the volume? It increased by 2. We can write 6 minus 4 equals 2. So the 4 increased by 2 and became 6. This means that the two balls are 2 milliliters. And since the two balls are the same, if both are 2, then each one of them is 1. 2 divided by the two balls, then each one is 1 milliliters. So this is how, by using the water displacement method, we can find the volume of any object. Now please copy the answers on the book and then write down the water displacement method on your copybooks. Study well. Thanks for watching.